During his keynote speech at the GTC 2024, Jensen Huang introduced the concept of Nvidia Inference Microservice, or NIM. These are pre-trained models. They can be language models, computer vision models, robotic models, any model, and mostly open source, whether they are from Nvidia or other companies or partners. The goal is to make it easier for companies using Nvidia GPUs to train models with their own proprietary data. During the keynote, Jensen Huang left out some details that were unveiled by previous speakers or by Huang himself at previous events. We put the different comments together to show in more details how with NIMs a company can rely on a team of digital experts. Take a listen.
This software comes basically in a digital box. We call it a container, and we call it the Nvidia Inference Microservice, a NIM. Someday there's going to be one of these chatbots, and these chatbots is going to just be in a NIM, and you'll assemble a whole bunch of chatbots. Maybe it's some basic calculator. Maybe it's pandas to do some numerical analysis on it, and then it comes back with its answer, and it gets combined with everybody else's, and because it's been presented with this is what the right answer should look like, it knows what right answers to produce, and it presents it to you. And because these NIMs have been packaged up and ready to work on your systems, so long as you have NVIDIA GPUs in your data center or in the cloud, this NIMs will work together as a team and do amazing things.
This concept was first introduced by Jensen Huang during the 2023 edition of the GTC and was in reference to language models only. The name was Nemo, a cloud service for customers that want to train large language models and generative AI with their own proprietary data. Take a listen.
Some companies need to build custom models with their proprietary data that are experts in their domain. They need to set up usage guardrails and refine their models to align with their company's safety, privacy, and security requirements. NVIDIA Nemo is for building custom language text-to-text generative models. Customers can bring their model or start with the Nemo pre-trained language models, ranging from GPT-8, GPT-43, and GPT 530 billion parameters. Throughout the entire process, NVIDIA AI experts will work with you, from creating your proprietary model to operations.
Also on that occasion, Jensen Huang left out some details, like he didn't say that Nemo was developed first as a tool for NVIDIA own engineers. Bill Daly is NVIDIA Chief Technology Officer and gave some details in front of the students at the Paul G. Allen School of Computer Science only a few months before GTC 2024.
We have a model we use within NVIDIA that makes our hardware designers more productive. We call Chip Nemo. Nemo is our general large language model. And Chip Nemo has been pre-trained on 24 billion tokens that we basically scraped from the architecture documents, Verilog code, scripts, and everything that we've been using to design GPUs since the mid-1990s. And probably the most productive use of Chip Nemo is saving senior designer time, because the senior designers spend a lot of time answering questions from junior designers like, how does this texture unit work anyway? And they can ask that question to Chip Nemo and actually give them a pretty cogent answer because it's read all the architecture documents about the texture unit.
From industry publications, we then found out that the model was developed in 3 phases. First, NVIDIA used its foundation model, that is a neural network trained on a huge amount of raw data, generally with unsupervised learning, that can be adapted to accomplish a broad range of tasks. It is made up of 43 billion parameters that learn from 1 trillion tokens, the fundamental language units. Then, the second step was to train the model on 24 billion tokens of company data, that is the entire history of NVIDIA in chip manufacturing. Of these 24 billion tokens, 12 billion came from design documents, bug reports, and other English language internal data created by NVIDIA during the development of chips for the last 30 years. The other 12 billion tokens came from lines of code and scripts written since the 90s, also at NVIDIA. Then there is a third phase called Retrieval Augmented Generation. In this step, the model is given access to real documents that act as a sort of checkpoints. This is a way to support with real data the suggestions made by the model. Without this step, the large language model would have higher probabilities of hallucinating, which means producing the wrong information. Following the previous step, Chip Nemo was set up to perform also two more tasks: EDA tool scriptwriter and summarizer of bug reports. As EDA tool scriptwriter, Chip Nemo helps engineers to run tests on designs by providing a natural human interface instead of some very arcane commands. As a summarizer instead, Chip Nemo analyzes and summarizes bug reports. Traditionally, each bug can be documented with many pages of detailed data that are sent to a designer for a fix. Chip Nemo summarizes the bug documentation into as little as a single paragraph and can write a summary in two versions, one for the engineer and one for the manager. And this again is made possible because of all the knowledge acquired in Nvidia database in 30 years of documents and code, something that other EDA companies don't have. And all of this came together at GTC 2024, when Jensen Huang gives a practical example about how his engineers use the chat box today.
So we got ourselves a Llama 2. This is a 70B, and it's packaged up in a NIM. And we asked it, what is a CTL? Well, it turns out CTL is an internal program, and it has an internal proprietary language. But it thought the CTL was a combinatorial timing logic, and so it describes conventional knowledge of CTL. But that's not very useful to us. And so we gave it a whole bunch of new examples. This is no different than onboarding an employee. We say, thanks for that answer, it's completely wrong. And then we present to them, this is what a CTL is, okay? And so this is what a CTL is at NVIDIA. And the CTL, as you can see, CTL stands for Compute Trace Library, which makes sense. We were tracing compute cycles all the time, and it wrote the program. Isn't that amazing?
The NVIDIA CEO is obviously pleased with the results.
And how much more enjoyable is that? For our software team, they just chat with the bugs database. How many bugs was there last night? Are we making any progress? And then after you're done talking to this bugs database, you need therapy. And so we have another chatbot for you. So we call this Nemo Retriever, and the reason for that is because ultimately its job is to go retrieve information as quickly as possible. And you just talk to it. Hey, retrieve me this information. It goes, it brings it back to you. Is it, do you mean this? You go, yeah, perfect. Okay? And so we call it the Nemo Retriever.
Just like he did in 2023, Jensen Huang compares NVIDIA to the chip manufacturer Taiwan Semiconductor, or TSMC. In the same way that TSMC produces the chips that technology companies need but cannot afford to make, NVIDIA provides the expensive infrastructure that companies need but cannot afford to develop.
We will do for you and the industry on AI what TSMC does for us building chips. And so we go to TSMC with our big ideas, they manufacture it, and we take it with us. And so exactly the same thing here. AI Foundry, and the three pillars are the NIMs, Nemo Microservice, and DGX Cloud.
And so here are more details about how companies can train a neural network, like Chip Nemo, with their own data.
Proprietary information. Remember, inside our company, the vast majority of our data is not in the cloud. It's inside our company. It's been sitting there, being used all the time, and gosh, it's basically NVIDIA's intelligence. We would like to take that data, learn its meaning, like we learned the meaning of almost anything else that we just talked about. Learn its meaning, and then re-index that knowledge into a new type of database called a vector database. And so you essentially take structured data or unstructured data, you learn its meaning, you encode its meaning, so now this becomes an AI database, and then that AI database, in the future, once you create it, you can talk to it. And so let me give you an example of what you could do. So suppose you've got a whole bunch of multi-modality data, and one good example of that is PDF. So you take the PDF, you take all of your PDFs, all your favorite, the stuff that is proprietary to you, critical to your company. You can encode it, just as we encoded pixels of a cat, and it becomes the word cat. We can encode all of your PDF, and it turns into vectors that are now stored inside your vector database. It becomes the proprietary information of your company. And once you have that proprietary information, you can chat to it. It's a smart database. And so you just chat with data.
Once again, Bill Daly gives more technical details about the steps.
But then you also, it's really important to make it something that people respond well to. So you like to fine-tune it further by having it generate a couple responses to a query and then having humans grade those responses. By giving feedback from those human responses, you can wind up getting the model, producing responses that people like better. And the human in the human feedback reinforcement learning is hugely important to getting good quality out of this. So now you have your specialized model, and now you get to where the rubber really meets the road. And in the long term, the bulk of computation for deep learning happens on the inference side. It's interesting, early on in these explorations, there's a lot of effort in training because people are experimenting a lot. But once they get the formula right, they'll retrain these models periodically. But they'll train a model and they'll do inference on it for months, if not longer, before they go back and do the whole process again. And so an enormous amount of stuff is running on the inference side. Even though each query takes maybe a second of GPU time, you're doing enough of it, it actually swamps the months you spent training over on the other side. The recent addition to this slide, and I kind of shoehorned it in here, is this retrieval button. And this is probably something that's become really commonplace in maybe the last 4 or 5 months, is to do retrieval augmented generation, where sort of before I run the large language model in inference, I take my query, I actually use it to query a database, pull up all the relevant documents. And so for Chip Nemo, we go back to this original 24 billion token database of documents, pull up all those architecture documents, and then we feed them along with the original query into the input window of the transformer, and then run the inference code on it. And this prevents your large language model from using psychedelic drugs and hallucinating. It basically grounds what it's doing in actual documents. It can give you references to documents that are real and greatly improves its accuracy.
The final step is very simple. Just visit the Nvidia website for the free resources.
And these packages, incredible bodies of software, will be optimized and packaged, and we'll put it on a website. And you can download it, you could take it with you, you could run it in any cloud, you could run it in your own data center, you can run in workstations if it fit, and all you have to do is come to ai.nvidia.com. We call it NVIDIA Inference Microservice, but inside the company we all call it NIMs.